The world stopped its breathing as the James Webb Space Telescope left on an unequaled mission to the most significant regions of our planetary gathering. It was a leading achievement. It meandered where no space mechanical assembly had gone previously, the chilly profundities of Pluto. The picture the telescope sent back was baffling, showing nuances of Pluto that had never been seen before. It showed the most raised mountains, which could challenge the imaginative brain, beautiful valleys, and old pits. And afterward, there was Pluto's famous cold and bone-chilling heart, an immense mystery that continues to perplex scientists. Why is NASA reinvestigating Pluto with the James Webb Space Telescope? And how does this continuous examination of Pluto prepare for future missions to the outside scopes of our planetary gathering? Every progression and present-day development opens another part in the story of our space examination endeavors. Recall that we have, in all likelihood, made giant strides forward in our space mission since Neil Armstrong set foot on the moon. Still, the immense universe and our inability to loosen up totally all of the mysteries of the universe are a steady reminder that there is so much we truly need to realize. This is where NASA's imaginative exercises and instruments come in. The James Webb Space Telescope, JWST, was sent off to uncover faraway universes and peer into the start of the universe above. This telescope is a breathtaking extension of NASA's past missions. The intensity of understanding gigantic mysteries of the past is an unbelievable encounter. We are at this point curious about the Big Bang and the improvement of our planetary gathering. More basically, we try to consider whether there might be an obvious answer to the opportunity of extraterrestrial life outside our home planet. Could our knowledge into the close-by planetary gathering form into another field of study? Will the new information collected through the James Webb Telescope force us to reevaluate our focal points of view on the universe? These requests prompt a study of our progressing data, especially our perception and portrayal of Pluto as a diminutive planet. Due to the New Horizons mission and its imperative exposures, we've been able to find out about Pluto. The billion-dollar theory has vexed NASA's undertakings and expanded how we could decipher the chilly planet. Before the New Horizons mission, our knowledge of Pluto's surface was insignificant. The most organized picture we had, taken by the Hubble Space Telescope in 2002, uncovered a confusing mix of assortments on Pluto's surface. The tones included shades of orange, white, and dark, alongside an awe-inspiring spot that got scientists' thoughts given the inconsequential few nuances presented by the Hubble Space Telescope. Looking at Pluto was like attempting to settle a puzzle with only a few obscured pieces. Then the James Webb Space Telescope appeared on the scene. It ventured into Pluto's orbit, taking several stunning pictures that gave specialists a totally different understanding of that planet. The scene was like being given a backstage pass to an enchanted show and finally having the chance to see all the amazing things that had been hidden away from us. These photos intrigued scientists as well as captured the imaginative minds of numerous people all over the planet. It ignited a new surge of interest and energy for the dark regions beyond our planetary region. In July 2015, the New Horizons spacecraft performed its fundamental goal of flying by Pluto and its many moons, sending back the fundamental unequivocal photographs of this glorious body to Earth. This junction in history has turned out to be a huge forward-moving step in space examination. Cosmologists obtained data about Pluto and its moons that they didn't have beforehand. The progress of the New Horizons mission opened various avenues for NASA to research the tremendous range of the Kuiper Belt. Recognizing the desperate necessity for a solid understanding of great bodies, NASA focused on planets located between Neptune's orbit and nearly 50 astronomical units from the Sun. The most striking accomplishment of the mission was undoubtedly the close flyby with Pluto and its most prominent moon, Charon. Additionally, New Horizons captured clear pictures of Pluto's four unique moons: Nix, Hydra, Kerberos, and Styx. The course of data analysis required 15 months, and by October 25, 2016, the objective was achieved. The spacecraft had gathered 62.2 gigabytes of critical information. Yet, what is the meaning of this huge amount of information for how NASA may decipher the minor planet later? Data analysis of the discoveries from the New Horizons mission was so interesting that scientists needed to create new cutting-edge data models to interpret the results in time. Obviously, Pluto was subject to electrifying surface and climatic variabilities that conflicted with the initial assumptions. Despite its renaming as an undersized planet, Pluto showed a strong nature. It evolved at a rate that prompted NASA to re-examine and change existing data about it. NASA's high-resolution images of Pluto reveal fascinating insights into this distant dwarf planet. One striking feature is Pluto's heart-shaped region, aptly named the Heart of Pluto. This topographical idiosyncrasy, formerly named the Sputnik Planum, plays a huge role in shaping a significant portion of Pluto's surface features. Surprisingly, this heart-shaped district isn't warm and throbbing but is instead cold, chilly, and almost frozen. In reality, it's a massive expanse of nitrogen ice spanning more than 1 million square miles. The presence of this immense nitrogen ice sheet at Pluto's heart has significant consequences. It is responsible for a cycle called true polar wander, which causes the planet's rotation axis to shift. Before NASA's New Horizons mission, scientists were unaware that Pluto's heart-shaped bowl leans opposite its largest moon, Charon. This reorientation of Pluto has fascinating results, especially in relation to the connection between Pluto and Charon. In straightforward terms, the design of Pluto's heart-shaped bowl, combined with the rotation between Pluto and Charon, suggests that the heart's presence influences the planet's tilt. This implies that the gravitational interaction between Pluto and Charon, combined with the presence of the Sputnik Planum, has caused Pluto to tilt slightly on its axis. This newly discovered insight reveals why Pluto is such a dynamic and intriguing world. Despite being unappealing to some, Pluto's icy surface and the massive nitrogen ice sheet at its center contribute to its remarkable characteristics, including its tendency to tilt due to imbalance and its mass. Pluto's enormous mass, combined with the gravitational pull of its moons, can trigger a phenomenon known as a polar wander. This occurs when a planet shifts its axis to a better orbit. However, the presence of the thick ice sheet alone is not enough to cause such a significant deviation. While the massive ice sheet contributes to Pluto's mass, it is not the only component driving the dwarf planet's tilt or the substantial rotational forces experienced in its development. Recent technological advancements have allowed scientists to delve deeper into Pluto's secrets, leading to a major revelation. Surprisingly, Pluto has a subsurface ocean hidden beneath its icy skin. This is a groundbreaking discovery, as it challenges our previous scientific assumptions about the planet's composition and origins. The presence of an ocean as one of Pluto's internal components radically alters our view of this distant moon, placing it among other ocean moons in the nearby planetary gathering, such as Titan, Enceladus, and Europa. Although there is currently no evidence that life could exist in Pluto's ocean, the mere possibility makes us question whether extraterrestrial conditions could be viable. This revelation provides grounds for considering life beyond Earth and raises the stakes for exploring and finding ocean worlds in our planetary system. NASA also recognizes that despite the lack of conclusive proof, extraterrestrial life remains a viable hypothesis. Another significant revelation through NASA's Cassini mission was an ocean rich in phosphorus beneath the icy surface of Enceladus, a moon orbiting Saturn. This finding has sparked ongoing discussions about the possibility of extraterrestrial life, since phosphorus is essential for the formation of DNA and RNA, fundamental components of life. Despite the potential of Enceladus as an astrobiological focus for space research, assessing the habitability of Pluto takes a new direction. Pluto's case is unique because, while its imaging equipment is advanced enough to capture detailed photographs of its surface, it is not equipped to test its habitability. This inability to determine the precise chemical composition of Pluto's subsurface water makes it challenging to expand our knowledge and definitively determine whether Pluto can support life. NASA continues to invest in exploring icy worlds like Pluto, but the technology for analyzing the composition of its oceans is non-existent. Nevertheless, this does not diminish the value of studying Pluto. The planet offers insights into various aspects of planetary science, from understanding its geological features to unraveling its origins. Each new discovery enhances our knowledge of the nearby planetary system and fuels our curiosity about the possibility of life beyond Earth. As we delve into higher-resolution images of Pluto, the planet appears to offer something new to discover. Additionally, Pluto is just one of potentially numerous dwarf planets in the Kuiper Belt. It is truly intriguing to contemplate the wonders that could exist on other dwarf planets, like Haumea or Makemake, which we have not yet had the opportunity to explore. Hopefully, one day we will have the chance to witness their icy splendor and uncover the secrets they hold. With the launch of the James Webb Space Telescope, we stand on the brink of a new era in space exploration. Pluto's status as a dwarf planet is rapidly becoming a relic of the past, as NASA reveals clear images of refined geological features that have recently emerged on its surface. The remarkable pictorial references mark a significant advancement, showcasing the unique nature of this distant world. It's groundbreaking to think that a few gigabytes of data could open up a vast expanse of tremendous opportunities for us. The wealth of information amassed by missions like New Horizons and the James Webb Space Telescope offers new insights into the secrets of our universe. With each new discovery, we inch closer to understanding the complexities of celestial bodies like Pluto and uncovering the mysteries they hold. Without a doubt, the potential